Good Thanksgiving, neighbors. Hope you're having a good turkey day. The Geiger counter. I think I spoke to this some 800 videos ago, 600 videos ago. It really is two circuits. One is the detector circuit, the other is what builds the display. Analog detector, digital computer. Pretty slick stuff. So these measurements, because I trust the meter, I understand it, I know what they are and can do, are just a matter of record, matter of history. It's a hobby. Check out our daily radiation dose. Now this is a relative measurement, right? Because it doesn't measure everything. It measures very specific things. The counts are what it's actually seeing, and that measurements in microsieverts, right, per hour is a derived number based upon this tube's characteristics. There's one number you enter in there that is a multiplier for what the counts coming off the detector are. Could be considered interesting stuff. So what is this? This is based purely on, can I get it to see it? This little round pancake tube. It's called a scintillation, well, it's called a Geiger-Müller tube. It operates off of 500 volts. Very precise, temperature corrected and adjusted 500 volts. That 500 volts energizes a grid in there and makes the electrons ready to come off of that grid very easily. So one of the three types of energy this tube, this Geiger-Müller detector can measure. It can measure alpha, beta, and gamma energy. But I'm going to open that up a little bit further in a minute. So that 500 volt supply is the key, is the driver behind the quality of this instrument. It was made by a company that's well trusted, and they released some for this kit specifically, to be tied to this pancake tube specifically. Now covering that tube, you can see the grid kind of. That is a gold plated EMF cover. It's grounded to the tube, so basically it will cut off, eliminate any electromagnetic energy from, say, a transformer, even a cell phone. This cell phone, it does not detect, even though it's got a transmitter in there for microwave frequencies, right? It's got a Bluetooth transmitter in there on a different frequency, and I'm using it as a headset. So this is a microphone of sorts, but it is only used as a counting circuit. The tube itself has more abilities than that, with more sophisticated electronics and software analytics to go with it. It's a very powerful tube. It also operates at other voltages. It's characterized to operate at other voltages. If I had my druthers, I'd rather have this tube at 700 volts instead of 500. Doing that will increase the count rate, will increase all my background numbers, and I would have to change that correction factor, that multiplication factor for sieverts in there to correct it. That would be called a calibration. After the calibration, you'd certify the calibration. Calibration on this type of instrument is a single point calibration. It's basically, does it work or not? There's more to it, always more to it. So the gold covering on that tube, that gold plate, keeps out transformer noise, keeps out electromagnetic waves. It actually balances them, and the electronics takes care of that magic. Yes, its ground is floating. So this detector also has, this tube type has a mica cover. The reason it's mica and not glass is it does not attenuate, it does not absorb some of the energies that we're looking for. So this is an engineered component, well known, well characterized is the term for it out there in the science world. Come on, you can do something. Oops. So we go back to the reading side and we see, is it reading what it was a minute ago? 35. So it's bouncing around again. Long-term averages is what I'm hunting for. I've seen it go up to 50. I have one recorded instance of a 0 on this meter that I remember. Could be, no, one that I remember. Because in that location I also had a spike a little bit later in time. It had to be removed from my data to be uploaded because it was an unexplainable spike for this meter, for this type of measurement. So it was a legitimate remove from miles and miles of data. So back to this tube. There's one other I was mentioning. It has a mica film covering it. That big round black spot behind the gold is a clear mica covering. Very low impedance. In other words, it won't stop much from coming in. But you can't see through it because it's covered with a black coating, black paint. I had something spill on this and had to clean it off. And when I did, I removed the black paint. So there's a very small touch spot that you can't see with this camera, where I use some permanent black marker to cover it over. But while it was uncovered, it was the size of half a dime. I took it out into the sunlight to see, because I understand that this responds to sunlight. That's why the blackout is put on that mica covering. And when I took it out in the sun, it saw the sunlight. But now it doesn't see the sunlight. Putting in direct sun does not change the reading. Another long-term test I was wondering about is, does the sun impact the measurements from this meter? Does the rotation, whether we're facing the sun or on the back side of the sun, does that change what this meter sees? The answer is no. It did not for this meter. Another meter, another sensitivity type, different detector, different rules, can see these things. This is a world of high energy particle detectors. That's what this guy is. Very specific set of high energy particles. It excludes the electromagnetic spectrum by that covering of gold. That's why tinfoil hats work. But you need to ground them. Or do you need to ground them? Or are they grounded? So, that's this meter. The other side of it is all the computer and chip stuff. One of these chips talks to an array of satellites for GPS location. One of these chips writes to a SIM card, logging all the data for me, so I can go back and look at it, and I can choose to upload it to Safecast, and you can see the blue light on that. Hard to do. This is not a great YouTube's, is it? That's why I'm here. Oh, so there's one that's detecting in GPS locations. This is a very dated chip. It would be nice to have this well upgraded into a better integrated chip. There's multiple GPS location satellites, and you can use them, systems. You can use the different systems to actually make your location data even better. Ask the people in Ukraine. So that's the display. Somewhere under there is the CPU. There's a battery on the underside as well. Somewhere in those layers you can't see because of insulation. So this plastic case is what keeps it effectively from seeing alpha and beta radiation. You can test this idea, this thought, this theory, and I did 1,000 videos ago by using a radiation source removed from a smoke detector. Those are alpha emitters. They are bound, they are hard to digest, and they're well isolated. There's a tin can over them to keep you from playing with it. But using that as a source, a very high alpha energy source, reasonably high, and removing the cover, putting the cover back on, change the readings, proving the attenuation of this thickness of plastic, and you could make some numbers for it as well, what that attenuation number is for this type and piece of plastic, and you could do other plastics and see what their attenuation rate is. Alpha is very easy to stop. That's one of the concerns. Alpha particles do not travel far. Measuring alpha means that you are in somewhere, there are particles in the air releasing alpha contamination, right? You're inhaling those particles. And beta or gamma emitters. Oddly, those are typically heavier particles. They travel much deeper through you, but they have less statistical odds of hitting things, which is attenuation. So, that's a brief intro to a meter that goes back to civil defense rules, civil defense time. Somebody on this coast sat with meters like this, only with analog instruments, and a little swinging meter that went between 0 and whatever it went between, and they wrote logs and records, and those are in somewhere in CDC archives, buried near the city of Seattle. Should have gone up there, it's on my list. But this device is well enough known. If you can show the proper application of it, you can have a conversation about its meter readings. You could take it to somebody else and say, hey, what did I see? What is this? Or you can investigate and find out yourself. Nuclear fallout is spread across much of the nation. But there's other fallout, like coal. Coal dust contains that and many other elements and isotopes. This is the facts of measurements. So if you take this instrument and you hold it next to a much more sophisticated field survey type device, you can correlate the data. You can make well-known inferences, references to what this meter sees versus what a spectrometer sees. This meter is counting parts per billion. Isotopic analysis. This surrounds you. One of the first awesomes I had was going into a Texas Instruments semiconductor facility in Texas and servicing a lab instrument that verifies the quality of the materials that are in, guess what? Cell phones. Ultra high purity materials required for today's manufacturing. Tin cans, soda cans. Y'all have noticed how much thinner soda cans have gotten. Tin cans are no longer tinned. Most of them are aluminum, very recyclable material, but they've gotten thinner because we've gotten better. That's the land of high purity materials. So how high a purity can you get? Let's jump right into it. Iran is purifying uranium ore. Uranium ore consists of U-235 and U-238. You can go find technical facts on the ratios of uranium-235 and 238 in soil. So you go out in your backyard and you dig up a bucket of soil. Out of that bucket of soil, you won't get any of this. You can purify but there might be some there because you can't do it well enough. So we're going to jump into Iran. Iran's production of commercial nuclear fuel, which is what they are building. The next generation of reactors happen to like these higher quality fuels. And that's what we're talking about, is fuel quality. How good is your fuel? We're talking about ratios. Uranium-235 to uranium-238. Purified using gas centrifuges that back in the day, until very recently, were part of CFC releases into the atmosphere that helped destroy, change the ozone layers that we measure in the upper atmosphere. How good are we? How incredible. Humans are amazing. So, these meters, good meter is relative, but everything is relative. So these measurements, this Iranian fuel processing, the initial designs came from a company called Halliburton. Halliburton is one of the few multinational designers of nuclear fuel processing facilities, because we make nuclear fuel. Nuclear fuel is a lead-in to nuclear weapons fuel. U-235 plus U-238 equals Pu-238, I believe. Yes. But I can go, check the references. So they used to use CFCs, ozone-destroying CFCs, to process nuclear fuel across the globe. This was very few players, but this is a global enterprise. Make no mistake. This is big money for refueling contracts. 100 nuclear facilities in America, over 100. Every one of them with multi-million-dollar, multi-year refueling contracts. Breaking those supply chains. So, we're being played for wealth. So Iranian's nuclear fuel processing, I mentioned, came from a Westinghouse design that somehow an Indian nuclear engineer got a hold of and passed on to the Iranians. But Iranians now are sponsored more by Russian assistance and guidance. This level of thinking and engineering and design and testing, these are small rooms you work in. Yet, even during our nuclear lead up, what got us to today, I hope this microphone's working okay, I'm listening to music. So, this is all what got us up to today. The internet was invented, so a handful of nuclear research facilities, nuclear weapons research facilities could go and do their thing, because collaboration, family, contacts, friends, conversations build a planet with humans on it. All right, now we got 20 minutes. Whoa. Pieces out. Enjoy your day in company and food.